Hi friends, good morning. Today we are going to discuss another session of special function, that is Rodrigous formula of Hermite differential equation. Okay, Hermite differential equation. In the last lecture we have seen what is generating function of differential equation. Okay, and also using it we have seen what is h0 of x, that is equal to 1, and h1 of x, that is equal to 2x, and h2 of x, that is equal to 4x square minus 2, and so on. This all we have seen, right? Now what is Rodrigous formula? Rodrigous formula is a solution of differential equation, that is hn of x, solution of Hermite differential equation, that is hn of x, we can represent in terms of an exponential function, right? So minus 1 raised to n e raised to x square d raised to n dx raised to n e raised to minus x square. This simplest formula which can use to find this h0 of x, h1 of x, h2 of x, and so on. Okay, so let us verify this here. Okay, so to find this h0 of x, let me check these values that are getting or not. Okay, so to find h0 of x, so I can replace n is equal to 1 here. So minus 1 raised to n is n with 0, right? Minus 1 raised to 0, e raised to x square, d raised to 0, dx raised to 0, that is e raised to minus x square, right? So that is equal to minus 1 raised to 0, e raised to x square into, so this is 1. Okay, so this is no differentiation. Okay, so that means e raised to minus x square itself, that is equal to this will cancel, and minus 1 raised to 0, that is equal to 1. So we got h0 of x is equal to 1. Okay, now let us check h1 of x. Okay, what is h1 of x? h1 of x is equal to minus 1 raised to 1 e raised to x square into d by dx of e raised to minus x square, right? That is minus 1 raised to 1 e raised to x square into, what is d by dx of e raised to minus x square? That is e raised to minus x square into, when minus x square on doing, that is minus 2x, right? So this will cancel. So minus 1 into minus 2x, that is equal to 2x. So this also correct. Okay, now let us check this for h2 of x. Okay, so I can write this as h2 of x, that is equal to minus 1 raised to 2 e raised to x square into d square by dx square e raised to minus x square, right? So this is equal to 1 into e raised to x square into, again differentiate first time, so that is equal to minus 2x into e raised to minus x square. Okay, that is equal to e raised to x square into, so I can take this minus 2 out, right? So into minus 2, that is into minus 2 into d by dx of x e raised to minus x square. So I can differentiate this again, that is minus 2 e raised to x square into, so if I am applying product rule, first function into differential of second, that is e raised to minus x square into, I can write this as minus 2x plus second function into differential of first, that is equal to 1. Okay, now if I am taking this e raised to minus x square out, so this and when I am multiplying this and this all will cancel out. Then if I am multiplying to here, so this will be 4x square. So let me write this minus 2 into, this will be minus 2x square plus 1, right? So when I am expanding the bracket, this will be 4x square minus 2, right? So this is h2 of x. So we can generally express this hn of x as like this. Okay, now suppose if you find, I can write from this some general equations. Hn of 0, that will be 0 if n is odd, and minus 2 raised to n by 2, n minus 1 double factorial for even. Okay, so let me check. We have already discussed this h0 of x, that is equal to 1, h1 of x, that is equal to 2x, and h2 of x, that is equal to 4x square minus 2. Okay, now if h0 of x, if you are finding h0 of x, so if you consider n is odd, okay, n is odd, so if for h1 of x, so n is equal to 1, that is an odd. Okay, so let me check. h1 of x is equal to 2x, so if you find h1 of 0, that will be equal to 2 into 0, that is 0. So if n is odd, this n is odd, the function value will be, that will be equal to 0. Okay, now if n is even, so let us check that condition. So this hn of 0 is equal to, hn of 0 is equal to, that is minus 2 raised to n by 2, n minus 1 double factorial. Okay, so let us consider h2 of 0. h2 of 0 means what? That is minus 2 raised to n by 2, that is 2 by 2 into 2 minus 1 double factorial. Okay, so we can write this as minus 2 raised to 1, that is equal to minus 2 into 1, right? That is h2 of 0 is equal to minus 2. So if you substitute x is equal to 0 here, h2 of 0, that is minus 2, this part will be 0. So h2 of 0 is equal to minus 2. So this will be a correct formula. Okay, so hn of 0 you can write as 0 for n is odd. hn of 0 you can write as minus 2 raised to n by 2, n minus 1 double factorial for n is even. And also we can write this formula, this I can generalize for odd functions, that I can write as h2n plus 1 of 0 is equal to 0. This I can generalize. Okay, odd function means here I can give n is equal to 0, 1, 2, 3. When you give n is equal to 0, you will get first order function, that is h1 of 0. Okay, that will be equal to 0. And if you give n is equal to 1, you will get h3 of 0, that will be odd function, that is 0. So if you generalize the even result, that is h2n of 0, if you give n is equal to 1, 2, 3, etc., right, h2 of 0, that is equal to, you can generalize in this format. Okay, so that is minus 1 raised to, you may generalize, so if you give n is equal to 1 here, so this become h2 of 0, that is equal to minus 1 raised to 0, h2 of 0, that is minus 1 raised to 2 into 2 into 2, that is whole factorial divided by 2 factorial. Okay, so that is equal to minus 1 square, that is 1, right? Okay, so minus 1 raised to n, we are substituting n is equal to 1, right? So let me write 1, n is equal to 1, that is 1 into 2 into 1 into 1 factorial. Okay, so that is equal to minus 1 raised to 1, that is minus, and this is 2 factorial, right? So that is equal to 2. So h2 of 0 is equal to, when I am substituting x is equal to 0, this part will be 0, I will get minus 2. Okay, so generalize we can equation like this. Okay, so these are the general equations to find h even, h of even function. Okay, h even and h odd. Okay, this is also very important. Okay, so this is all about this Rodrigous formula. Okay, in the next section we will discuss about this orthogonality relation. Okay, thank you.